Example 9. Using the discriminant. Evaluate the discriminant for each equation, then use it to determine the number of distinct solutions, and tell whether they are rational, irrational, or non-real complex numbers. So if we take a look at part A, we have 5x squared plus 2x minus 4 equals 0. The value of A is 5, the value of B is 2, and the value of C is negative 4, according to the standard form of a quadratic equation. So now we're going to use the discriminant, b squared minus 4ac, to determine what's happening with these solutions. So the value of b is 2, and then we're going to square it, minus 4 times the value of c, which is 5, times, the value of a, which is 5, and the value of c, which is negative 4. Okay, so we get 2 squared, which is 4, and then we know we have a negative times a negative in these numbers, so we're going to get a positive. 4 times 5 is 20, and 20 times 4 is going to give us 80. And so therefore, we're going to get 84. Okay, so technically, we know it's greater than 0. We know that if we take the square root of that, it's going to be plus or minus. So we have 2 solutions. Okay, it's positive solutions, and we also know that it's going to be an irrational number because it's not a perfect square. So they're irrational solutions. Okay, all right, now let's just verify that looking at the graph. So if we put the graph in for 5x squared plus 2x minus 4, okay, you can see here that we have a solution here and a solution here, and it's going through the x-axis. Therefore, there's 2 solutions, but these answers here are irrational, and therefore that it verifies our answer here. Okay, let's go to part B. So in this case here, we need to subtract or add that 25 to both sides. So we have x squared minus 10x plus 25, and then we're going to set that equal to 0. We know that A is going to equal 1. We know that B is equal to negative 10. And we know the value of C is equal to 25. Now let's go ahead and plug in the discriminant, which is b squared minus 4ac. B is negative 10, and then we're going to square that, minus 4 times the value of A, which is 1, and then times the value of C, which is 25. So negative 10 squared is 100. Minus 4 times 1 times 25 is 100, so we get 0. So the square root of 0 is just going to give us 0. Okay, so that basically tells us that we have one, okay, solution, but it's a double solution. Okay, let's go ahead and verify that on Desmos. Okay, so again, we're going to put in our quadratic equation, which is going to be x squared minus 10x plus 25. Okay, here you can see that we get one solution. It touches the x-axis, and that means it's a double solution. So let's take a look at this last example. In this last example, we have 2x squared minus x plus 1. We know the value of A is 2. The value of B is negative 1, and the value of C is positive 1. Again, we're going to plug it into the discriminant, b squared minus 4ac. We know that B is negative 1, and then we're going to square that, minus 4 times the value of A, which is 2, times the value of C, which is 1. Negative 1 squared is positive 1, minus 4 times 2 times 1, which is 8, which gives us negative 7. So that means that we're going to have 2 solutions, plus or minus, that has an imaginary number. So we're going to have 2 solutions, but since we get an imaginary number, they're going to be non-real complex numbers. Okay, and then to verify that, we're going to go ahead and plug in our equation on our calculator, Desmos. So if we put in 2x, see here, 2x squared minus x plus 1. So you can see here that the parabola does not cross the x-axis, which means we do not have real solutions. We still have two imaginary solutions, but it's the square root of 7, which technically is going to be two imaginary irrational solutions. But therefore, since it doesn't cross the x-axis, you can see and verify that.